So, to start our great and positive session today, good morning, everyone from London, and good evening, good afternoon for those who have time differences. Dear authors and invited guests, it's my great pleasure today to welcome you to the 6th International Congress on Information and Communication Technology through Zoom on behalf of ICICT 2021 and Global Knowledge Research. Unfortunately, as every one of us passing through unseen and very hard circumstances due to COVID-19, we wish everyone and their families a safe time. And for sure, with the efforts of scientific people and scientific research, we will all pass through this very hard situation and we will see the light and get back to our normal life. Further, I have a good news that this year, with immense happiness, I would like to share that we have received an overwhelming responses to this conference. Over 90 countries, 1,150 papers. Across them, 350 were accepted. I'm sorry, it seems. Yeah, I thought that there is disconnection. Yeah, sorry. Over them, 350 were accepted, and based on that, these papers will be published in the next 4 volumes for sure this year. So we are thankful, dears, for being part of this virtual and digital conference. We highly appreciate your efforts and support, even that each one of us is passing through hard circumstances, but we are all turning it to be positive by contributing to the knowledge. And we hope that you will enjoy our second day today. And based on that, I would like to start positively our technical session 4A. And the best thing to start with is to welcome our chair from Italy, which is a very nice country that I personally and extremely love, Dr. Libro Negro. Dr. Libro Negro is a professor of computer engineering in Department of Informatics Modeling, Electronic and System Science at of University of Calabria in Italy. He currently teaches object-oriented programming and system programming, including covering modeling, simulation modeling, checking real-time and multi-agent systems course. He heads the software engineering department at the same university, whose main goal is formal modeling using many techniques such as actors, state chart, timed automata, and so on, and many tools such as for the analysis as well, such as throughout the statistical model checking and concrete implementation of parallel distributed systems with timing constraints and such a cyber physical systems. So most welcome our chair, and we are pretty sure that we will have a valuable input as usual, and all of our guests will be benefited totally from your experience, from your advices, and for sure they will be ready to answer the questions. The first presenter will bring us a paper titled as PRL-OC, extension of PRL protocol for LLN networks based on the operator calculus approach. So welcome, Mr. Muhammad Al-Amin, on behalf of your co-authors.
Okay. Uh, Good morning, everybody. We'll start to present. Wait a minute.
Yeah, please, could you please just share your presentation and the others, just a brief to make sure that all mics are off. We will have 10 minutes for the presentation, and I will raise this poll as a reminder. After that, we will at the 12 minutes, I will send another reminder to closure, and we will have 3 minutes more for the questions and answers.
I
So
would,
thank you for being coupled with us. Yes, Doctor.
I would ask the presenter. I would also say to the Mustafa that I'm here and also I can talk not just in a wonderful English, but I can talk also with the speakers. And I would ask to the first speaker, please, to focus on the main issues of your approach and the results. Please, you can start the presentation focusing on the main part because time is
It's very
direct.
short. Yes. Okay.
Yeah.
Okay.
Thank you, Dr.
Can I start?
Yeah,
Yes.
sure.
Okay. Okay. Hello everyone. Actually, I'm Abdul Sharif from National University Jakarta, Indonesia. And today I'm going to present our paper entitled RPLOC, extension of RPL protocol for LLN networks based on the operator calculus approach. Okay, as an introduction, maybe we have already know about smart city and IoT or Internet of Things. However, these technologies rely on various networking protocol, right? Because without protocol, it won't work. However, routing protocol for LLN or low power and lossy network or RPL, while constructing the paths from source to the destination, it uses a single metric. It's called ETX, where ETX describes the expected number of transmission required to successfully transmit and acknowledge a packet on a wireless link. And RPL looks at the neighbor statistic module, and then ETX is calculated based on the packet delivery of forward and reverse direction. However, this mechanism may arise some problem that, for example, the node could lead to the high latency, and then maybe some battery of node are exhausted. According to a survey paper, since RPL was launched in 2012, more than 90 RPL variants are published in order to improve RPL. In this work, we propose RPLOC, which is an extension of RPL based on the operator calculus approach. It provides an end-to-end optimal path by taking into account multimetrics such as ETX, latency, energy, and RSSI. And in this research, we have conducted some simulation and performance analysis between RPL OC, our proposed algorithm, RPL standard, and OFFL. The objective of this research are to optimize RPL routing protocol by using the operator calculus approach and to determine the end-to-end optimal path from source to the destination. Okay, here we will provide a short review of our work, which is RPL based on the operator calculus. As I said in the introduction, RPL also uses multimetrics like energy, RSSI, delay, and ETX. So we prefer to find the end-to-end paths, which is respecting to the constraints. For instance, we select the path with the maximum energy, maximum RSSI, but with minimum delay and minimum ETX. The operator calculus can discover all feasible multi-constraint paths between a source node and a destination with a minimum hop count, which is by default. It means that the operator calculus can provide the best optimal path, I mean, from the global view of the network in the end-to-end manner. Okay, let's now see this example. For example, we have 6 nodes multi-weighted graphs as follow. Each edge is appointed a vector of positive weighted. The task is to find all feasible optimum paths from node 1 to node 5. And we have the constraint, for example, like this. The constraint is say equal to 30, 25, 30, and 35, which is mean this is the parameter that we want to respect. In a particular way, the operator calculus will construct the nilpotent adjacency matrix as follows. And finally, we will have the feasible paths that satisfying the constraint that we want. Okay, the simulation setup. Before we perform the simulation, we have contacted the author of OFFL and asked them gently to share the source code for comparison purpose. In the simulation setup, we are going to compare between our proposed work with the RPL standard and the OFFL. In terms of quality of quality of service measurement, we focus on performance indicators as follow, like packet delivery ratio, throughput, end-to-end delay, energy consumption, and duty cycle. And in order to investigate the protocols, we perform two scenarios. And the first scenario, to assess the throughput of the network by increase the data traffic from 1 packet per minute to 60 packets per minute. And in the second scenario, we conduct a test where some nodes drop one by one during 100 minutes of simulation. And the result from the scenario 1, as seen in the figure 1, when the data rate is set to 60 packets per minute, RPLOC provides an average throughput around 3 kilobit per second, and RPL standard achieve around 2.8 kilobit per second, and the OFFL obtains around 2.3 kilobit per second. This phenomenon is caused by our method that provides the optimum end-to-end path with respect to the constraint in order to deliver the packet to the root. And in terms of delay, RPLOC obtain lower delay compared to others, as seen in figure B. And this is due to the fact that RPLOC select the path according to delay matrix threshold while constructing the paths. And figure
Sorry for interruption. 1 minute is left, please.
1 minute. Okay.
I'm sorry.
Sorry. Okay. We'll continue to the second scenario. The result, in generally, our protocols outperform than the others. As you can see, for example, figure B, for example, for end-to-end delay, or figure C, as you can see that the energy consumption are better than the other. As conclusion, this paper present our proposed algorithm on routing protocol RPL based on the operator calculus approach called RPLOC. And we remark that RPLOC has capability to find the optimal paths and communicate them to the nodes during the construction of the routes in a semi-distributed manner. In addition, from this evaluation, we can say that the proposed RPLOC is superior and outperforms than other algorithms. In this case, RPL and OFFL. Thank you very much for your attention.
Okay. Thank you for the impressive presentation, and now we will give it back to our chair for his feedback. Yes, doctor, we are listening to you.
Ask to the presenter some curiosity about the presentation. You talked about the approach based on operator calculus, okay?
Yes.
And you also talked about simulation and performance evaluation of some metrics, delay, latency, etc. But operator calculus is a mathematical approach.
Yes.
So what kind, first of all, the first question is, what kind of tool you used actually for making the performance values you talked about? And in particular, I would discuss briefly about the limitation of this approach. For example, when we raise the number of nodes, what happens about the scalability of the approach? And after all, this approach is original in this paper or was already presented in another paper of yours?
Yes.
Thank you.
But okay. Thank you for your questions. First of all, I would like to explain about the tools. We were using tools what we call a Contiki OS. Actually, it's very very large tools to do simulation in IoT network or in low power LLM networks, and we develop modules.
Is an ad hoc tool or developed by your group?
We develop by our group. We develop in with using C++.
Oh yes, yes.
Yes. So it's a little bit complicated.
Okay. Just to understand.
Yeah, we develop it by using C and C++, and then we inject our code into the Contiki OS, the tools to do the simulation. And about the scalability, we define first with the random node. As you can see in our slide, we were using 6 node first. We developed in randomly to show how the impact our protocol with this topology.
Okay.
And about the scalability, I think it doesn't matter because we have already performed with 100 node in our simulation in local by using the same protocol for wireless sensor network, and we see that the performance is still good than the RPL standard. Voila.
The last question was about the originality of this work, because I know you have already presented this this approach in another paper in IoT SMS 2020, and so I would ask you briefly differences between what you have talked about now and the previous paper.
Yeah, the difference between the previous paper that we take the different parameter, we take different metrics. Before we only take 3 metrics, now we take 4 metrics, which is they don't send the same metrics because they don't have a different environment.
Okay. Thank you. We are in time, and so
okay.
Thank you very much.
Thank you for your
positive. Yeah, thank you for the
you.
positive discussion. And now we will move to our next presenter, who will present to us from India, Ms. Nakatha Tabassum, on behalf of the co-authors to present her paper, Joint Position Estimation and Synchronization of Clock in WSN. So the mic, the mic is yours, dear presenter, and we are all listening.
Okay, you can start.
Yeah. Hi, is there any technical issue or anything that we can help with? Yeah, it's brilliant. Yeah. Okay. Yeah, we can see the screen now. Could you please make sure that the audio is connected since we can't hear any voice?
The presenter should be Mapunya Seguari Semaka.
Yeah. 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 So Sorry, Miss, you can't hear the voice. Could you please double
This
check?
is the TED presentation.
Yeah, we can see the presentation only.
Sorry, just to synchronize. And is there any author of this paper, please?
Uh, yeah, the authors are names are mentioned here. It's Ms. Nakasha Tabassum and her co-author, I believe he's a doctor, Raja Shakar Berdar. Those are the names on the second line, doctor. Okay, so uh, is there anything that we can help with? Please chat me directly if there is anything because we can't hear. Otherwise, we will be moved to the next presenter.
Next presentation, okay.
Yeah, I'm sorry we can't hear you clearly, and we don't want you to miss the opportunity to present and have the positive feedback from our director. Yes.
Yes, so you can check your audio, and once it is done, you can direct next to message to Feroz. So she
Yeah,
will
yeah,
keep your
yeah.
presentation in the last, right?
Okay. We will shift the presentation and we will move to our next presenter. We are
Next presentation,
sorry for
yes.
the short notice, but now we will turn to another interesting paper titled as Introducing a Test Framework for Equality of Service Mechanisms in the Context of Software Defined Networking. Our presenter will be Mr. Rejansa on behalf of the co-authors.
Hello.
Hi.
Hello, please.
Hi. Hi. Could you please just go to the presentation, share your screen, and make it direct to the point to take most of the notes of our from our chair.
Can everyone see my screen?
Yeah, we can see the screen and we can hear you clearly. Go ahead, please.
Thank
We
you.
are
So,
listening. Yeah.
yes, good morning, good afternoon, and good evening. I am Josiah Ilyazar Rehensha from Ateneo de Manila University in the Philippines. Allow me to present my paper, Introducing a Test Framework for Quality of Service Mechanisms in the Context of Software-Defined Networking. So for a brief context, software-defined networking is a relatively new technology. One of its main features is the decoupling of the control plane and the data plane. An illustration of the architecture can be shown in the figure on the right. So what we have now is a logically centralized controller, which grants us centralized management of the whole network. And also we have forwarding devices that are now programmable. So we are able to control traffic on the fly, and because of its programmable nature, we can automate traffic. So for the research, the main objective is to create an expanded and generalized framework to test algorithms and network topologies in order to aid quality of service research in the context of software-defined networking. And we're also trying to extend it in a way that it will also be applicable for industry applications. Um, so this is the general overview of our test framework architecture. So the main components is test simulator, our mininet topology, and our SDN controller. So our SDN controller, we can think of it as our control plane. Our mininet topology, we can think of it as our data plane. So what we have on the right is QS functions pickle file. So uh, the general idea is that network researchers can just plug in their QoS mechanisms, define them via scripting or other methods, and then we will serialize them into Python pickle files, and then once they're serialized, we can load them into the SDN controller during simulation. And the test simulator, it runs the tests inside the mininet topology and outputs results as raw text files. So this is the full architecture of our test framework. Uh, Still our main components, and what we just have are just the configuration files and custom scripts that are required for network data definitions, QoS configuration definitions, and other custom scripts that may be required in order to perform experiments. So the tool we use, first we use Mininet, which is a network emulator. So our network topology is simulated inside in it, so we can create virtual hosts and virtual forwarding devices. For our SDN controller, we use the RIU SDN framework, which uses OpenFlow protocol. Just the main reason we used RIU was because we are more experienced with Python. And for our simulations, we simulated the two most common internet traffic, which is web traffic and streaming traffic. We used Apache Bench to simulate web traffic and VLC streaming to simulate our streaming traffic. And in order for us to get the latency results, we also simulated ICMP packets via ping. And in order to get bandwidth results, we use IFStat. So for our algorithms, we focus on class-based queuing, and we have four mechanisms. Basic, which classifies based on traffic protocol, whether it's web, streaming, and all the other types of traffic. Source class-based queuing, which classifies based on source IP address. Destination, which for destination IP address, and source destination for a combination of source destination IP address. So we tested each protocol for 2 test cases each. The traditional, wherein QoS will only be applied in a centralized core switch, and we tested it in an SDN method where QoS is distributed. So this is the network topology we use. We have the ones encircled here, the left. They are what we call the client leaf switches, and this switch here, switch 3, is our core switch. So for the SDN test case, quality of service is applied in switch 1 and switch 2. For our traditional core implementation of QoS is only applied in switch 3. And we have 6 servers, 3 of them are web servers, and the other 3 are video on demand servers for our streaming. For our results, for web transfer throughput, as you can see, in most cases, except for one, SDN generally perform better, slightly better, but still better. Raw IP data throughput, SDN still performs better in most cases. And for our latency via ping, in all cases, SDN performs slightly better. And also for our via streaming throughput, SDN still performs generally better. So in conclusion, the results show a similar pattern to the previous study of Chato and Yu in 2016, which shows that the test framework is correct. Secondly, leaf-enforced or SDN application of QoS generally showed better results, which shows the advantage of the distributed nature of SDN over the traditional centralized nature. And lastly, the test framework can also be applied to other fields in computer networking, such as security, traffic engineering. Might have to define how the performances will be evaluated. And that's all for my presentation. Main references from the previous study, Chato and Yu. Thank you.
Okay, thank you. Thank you for the presentation. The mic is yours, Abatur.
Any question, please?
We don't have any questions so far on the chat, so you will be our examiner for today.
I would only ask about the extensibility of this test framework. In particular, what kind exactly of QoS you have studied, and in which way the result can be practically exploited in real networks? Thank you.
Sorry, what was the first question?
Yes.
So, Doctor, could you just repeat the first question? Yeah.
The first question is about extensibility. the way in which your approach can be extended to, for example, to an arbitrary number of sides of the network.
So the extensibility of the QoS algorithms can be used for it can be used for any algorithms actually. Basically, what network researchers only have to do is to define their algorithms and plug it into the framework, and the framework will serialize it for it to be used, for it to be deserialized in the SDN controller. Uh, yeah, that's one. For the second question, how can it be used in application? Well, for one, in research, it can help aid that network researchers no longer have to deal with the setup of its SDN with SDN architecture, and instead focus only in their algorithms. And the industry side, the idea is because of uh, uh, modern software engineering methodologies like Agile, where testing is very important, a very crucial part of the software development lifecycle. The idea is for engineers to be able to test their algorithms first before they deploy it to the actual networking system.
Okay, which is a subsequent work, I think. Okay.
Okay, thank you for
Thank you.
the presentation. Very informative idea, and for the questions and discussion. So now we will move to our next presentation, and I wanted to stress that if anyone has any question, please just push it to the chat, and I will share it with the chair and the presenter. Now we will move to another presentation from Indonesia by
Sorry, I
yes.
would check that I noted that Nikat Tabassum arrived, so we can go back to the first paper, previous paper, and so to allow Nikat Tabassum. Are you available, Nikat?
Yeah, she's ready, but I'm not sure. Do you want to make it now or to make it at the end of the whole presentation?
We can allow Nikat to make its presentation or go further.
Yeah, for sure. So, Ms. Nika, the mic is yours, and we will get back to your presentation. We hope that the audio issue is now solved. And
Yeah, can you hear me now?
yeah, we can hear you. It's clear.
Yes, we can hear you.
Yeah. So we are all
Thank you.
ready to listen to your presentation about joint position estimation and synchronization of the clock in WSN and on behalf of the co-authors. The mic is yours, and we are all listening. Thank you, dear.
Please.
Yeah, please just share your screen, and we are all motivated to listen
Can you
to
see
the
my
good
screen?
No, we can't see it.
Can you see my screen?
No, we can't see it. We can't see it.
Okay.
If there is an issue with the screen sharing, just push me the presentation to my email, and I will share it from my side. I will write it down.
Yeah, sure.
Yeah, I will write it again on the chat.
In the chat box.
Yeah, I wrote it. I will write it again.
Sorry for this delay because of me.
No, it's fine. We totally understand that it's not easy to go digitally and present it through Zoom.
Yeah, because in my laptop, I think it is not supporting that. So I'm just trying to present through my phone. I'll just share my PPT with you. I hope it is okay.
Yeah. Please send it to my email. And meanwhile, we will start listening to your brief introduction until having the PowerPoint ready.
Yeah.
Yes, you can say, share in the
Yeah,
message
I've sent
as well. There is, you know, where you send your message. to Feroz. There is also option you can send a file to her directly without email. If you have a with you in the mobile or something, there is option also available.
Upload it via chat. It's easy.
I have just now mailed the PPT. I have mailed the PPT to you. I hope you
have
got it.
mailed it. I did not receive it. I will double check. It's fine. We will make the most fast option.
There are problems. I can.
No, doctor. We are almost there. Just counting down, and the presentation will be here within seconds.
We can move otherwise to the Timotheus Suitono presentation and let allow to Tabasun to prepare and also check.
Yeah, doctor. Can you see my screen? I'm sharing it now.
Yes.
Yeah. So yeah, doctor. We are ready, and we are sorry for such a delay, but we totally understand. Again, this is
Can I start now?
Yeah, please start and make it brief to go to the direct point and save our time. Yeah, thank you, dear. Start again.
Yes. Sorry for the delay. And the topic for today is joint position estimation and synchronization of clocks in WSN. Ma'am, I think you can skip to the 8th PPT. We'll directly go to the methodology. So this wireless sensor, ma'am, can you go to the 8th PPT, 8th slide?
This one?
So wireless sensor networks, it is basically, it is a collection of various nodes that collectively collaborate, they sense data, and it is basically used for surveillance, target tracking, and other uses. So we have two issues, that is localization and clock synchronization. So traditionally till now, localization is finding the position of the node exactly where it is located. So either it can be a GPS coordinate or the exact coordinate, or it could be relative to the other nodes. And clock synchronization is synchronizing the clocks within the sensor nodes. So these two problems are dealt differently, but what we have done is we have tried to solve these two problems simultaneously. So the methodology that we are adopting is in the block diagram. So we have node Qi and node Qj. During this communication, they try to synchronize as well as find the position, that is find the distance between these two nodes. So initially the node Qi, it transmits a grading factor. So grading factor here, it is represented as omega, and Ti is equal to alpha it plus beta I. This is the clock synchronization equation, wherein alpha represents the clock skew and beta represents the clock offset. Clock skew is the difference in the frequency, I can say, if we take a clock cycle as a continuous, that's a sinusoidal waveform, and beta is the clock offset. So in order to have synchronization, we need to remove this alpha as well as beta. We need to make these two parameters as one, so that the synchronization is same for all the nodes. So to synchronize the nodes, we take the square root of the clock time multiple times, such that we get 1. So here by trial and error, we have taken 16 times. We have taken square root of the clock time period 16 times, and we have reached an accuracy of 1.000, that is corrected up to 4 decimal places. So this is how we synchronize the nodes. So in the first step, there is a timestamped message from node Qi to Qj with the grading factor, as that is depends on the synchronization grading factor, and then the node Qj, it transmits another packet to node Qi after a certain interval of time, that is C0, which is predetermined by the nodes. In the second step, the next slide, ma.
Yeah.
In the second step, node Qj, it receives a timestamp packet from QI after a certain interval of time, C0, which is assumed to be same between these two nodes. So once it receives a packet at time Tj2, it calculates the propagation time. So after calculating the propagation time, this will know the distance from QI. So once it knows the distance, third step, the next PPT, the next slide.
Yeah, this one?
No, just before that.
Yeah, this one?
Yeah.
Okay.
Yeah. So in step 3, so in step 3, again, a message from QJ to QI, it will give the offset, because these two nodes have already calculated, that is taken square root of their clock time. They have already reached 1. Only thing is they should know the difference interval between the two clocks. So this message, that is that this packet from TJ to TI3 will tell the offset time between two nodes. So that means beta is also eliminated from these equations, as we see. So at the end of step 3, we have found the distance between these two nodes, as well as we have eliminated clock skew and the clock offset. We have compared with another method, that is UWLS. It is a method wherein they have an initial estimate, and then depending upon the measurements, they try to fix, that is find the location and clock synchronizing the clocks simultaneously. So here we see that as the number of nodes increase, we have implemented this in MATLAB. We have taken around 100 nodes, which are randomly selected, and 50 iterations have been done on each value. So here we see that this clock synchronization for the proposed method, it is almost constant. As the number of nodes increase, the synchronization accuracy is almost the same. But here in the proposed, in the compared method, that is UWLS, the error actually increases along with the number of nodes increasing in the network. So by this, we can say that due to this accumulation error, that is in our system, we actually don't depend on the other clock's parameter. So that's why the accumulation error is very less, negligible, and it does not add up to the previous reference clocks. That is because of this, this error is very less, and it does not accumulate over, that is as the network grows, it does not accumulate. And we compare the localization accuracy as well. Since the localization, that is finding the distance between the two nodes, also depends on the clock. Since we are using the time of arrival method, this also affects the same way. Because of this less accumulation error, the position error is also less. And this is how it converges to 1. That is after 16 iterations, it converges to 1 with accuracy of 4 decimal points. And this proposed method, it synchronizes, that is, it removes the clock offset, clock skew, it finds the distance between the neighboring nodes, and it is very easy to implement compared to the other methods, and it is suitable for larger networks. So thank you.
Okay, thank you. Thank you for the great presentation. I have never thought of the clocks in this complexity, but thanks for the great efforts. Our chair, please, your input, questions, and feedback.
I would ask just a small question, because this work is very interesting, because it addresses the problem of the meaning of data which are originated in, for example, in several devices, sensors. Their meaning, which means that timing and localization are very important issues. Have you evidence about the application of this methodology to large wireless sensor networks? Have you some evidence? Besides any calculation and methodology, have you some experience about the real application of this approach?
Yes, yes, sir. Actually, these networks, whatever proposed method, it is suitable for larger networks. It can go up to even 500 nodes. And real applications like smart cities, there are various applications like traffic management, solid waste collection, then monitoring the structural health of the buildings. Then I can maybe name a few more applications that is for the smart cities. But generally, it can also be used for forest fire detections, forest fire detection, because these work over hundreds of kilometers. That is spacing between one node to the other node. It can vary from 10 meters to 1 kilometer. So this can be spread over very, very large areas to monitor. So effectively, this can be very effectively used in forest fire detections. That is currently we are working on that prototype. And this is also applicable in coal mines, especially because coal mines are underneath and GPS or other Wi-Fi or other internet facilities are not available. These wireless sensor networks are a promising network wherein the connectivity is good between nodes and the data can be taken out from the underground underneath to the surface.
Okay. And do you have, in your opinion, do you have some agreement that such a methodology, for example, could be used when data are originated from sensors and they have to be processed in real time? Because in IoT, there are sometimes the constraint that we must do something within a given time duration. And since there is clock synchronization, I have heard about, it is rather a convergent process. Do you think this kind of a methodology could be useful? I just asked in a real-time context application.
Yes, sir. Yeah, yes. In real time, yeah. In real time, yes, very much. It's really nice to have such a question. So in real time, it is possible, but we need to have more redundant nodes so that if one node fails, the other node takes up, and this clock synchronization has to be really tight in real time systems.
Okay.
I hope I have answered.
Okay.
I hope I have answered your question, sir.
Yes, yes,
Almost.
yes, that's fine. Ferris, can you please unmute? Sorry.
Yeah. Okay, another piece of idea which will be presented by Mr. Wotno. We are sorry for the misarrangement, but again, we are dynamic enough to go ahead now. His paper is a review of internet topology research at the autonomous system level on behalf of the co-authors. So we are all listening. Go ahead, please share your screen and let's start with the impressive presentation. Thank you.
Thank you very much for the time that already give to me. Have you see my screen now?
Yeah, we can see the screen. Go ahead, please.
Okay, good day everyone. My name is Timotius Witono. I'm PhD student from Universitas Indonesia. And the title of our paper is a review of internet topology research at the autonomous system level. The content of our presentation would be introduction and then method, result and discussion, and also conclusion. Internet topology can be inferred as the connection structures of many components such as routers, hosts, or autonomous systems. Research in this area are driven by the huge advancement of the internet and also by many problems that follow the progress. The division of the level of the internet topology can be divided into several levels, and the highest level is autonomous system level. And it is also the most prominent studies. One of the most prominent internet topology studies is at the level of the autonomous system. This is due of the highest level of granularity and its ease of gathering data sources. There are several motivations that stimulate researchers in the field of internet topology at the autonomous system level. The first is to see how does the internet look like. The second is to get information about certain topological properties. The third is to predict the future progress. And the last is to generate internet topology for simulation purpose. And also, in general, there are several motivations in network topology research, in scientific, adversarial, managerial, and also informational motivation. The purpose of this literature review is to find out the various contributions in research on internet topology at the AS level. And we do this method for our literature review. The search for various literature review is based on research question. There are 4 research questions that we established. The first one is, why do they need to be studied? Second one, how are they carried out? The third one, what are the limitations of current studies? And last one, what are the future studies of them? 3 digital libraries have been determined to search literature. They are SEM Digital Library, IEEE Explore, and also Scopus with keywords internet topology and autonomous system with the publication year between after 2009 and before 2020. This figure can explain the process of searching and selecting literature from 3 digital libraries from SEMDL, IEEE Explore, and also from Scopus. After that, we remove the duplicate, we exclude large paper because they are not included in our inclusion criteria. And after that, we include only 61 paper that we studies included in qualitative synthesis. This is the result and discussion. The following video shows the grouping of reference literature based on the 3 research categories in the field of internet topology, which is modeling, mapping, and also measurement. And also at the right side box, we can see the year publication of this literature. The results of the literature review are discussed in 4 subsections in our paper, according to the 4 research questions that have been set. Why do they need to be studied? How are they carried out? What are the limitations of current studies? And what are the future studies of them? In each subsection, the result of the literature review also divided into 3 parts. So we have 4 subsections, and in every subsection, we divide it into 3 parts, which is internet topology modeling, internet topology mapping, and internet topology measurement. This subdivision was chosen by considering 3 broad categories of research in the field of internet topology at the autonomous system level, namely internet topology modeling, mapping, and measurement. Here, the following table lists the result of the literature review on RQ1. Why do they, or definitely internet topology modeling, mapping, and measurement, why do they need to be studied? There are several lists. I would not explain it one by one. It's already explained in our paper. And also the result and discussion for the second research question, how are they carried out? How are they internet topology modeling, mapping, and measurement carried out? I would not read it one by one. It's already explained in our paper. And the research question number 3, what are the limitations of current studies on internet topology modeling, mapping, and measurement. It's also already explained in our studies. And last research question, what are the future studies of them? Internet topology modeling, mapping, and measurement. It's also already explained comprehensively in our paper. I jump to the conclusion. The literature review has been carried out on studies that contain keywords internet topology and autonomous system, involving 61 literature published in the last 10 years from 2010 to 2019. In general, internet topology research at the AS level can be grouped into 3 broad groups, namely internet topology modeling, mapping, and measurement. We go to the first one, internet topology modeling. We have specific conclusion for them. The most dominant reason in internet topology modeling research is to develop the internet to a better level, whereas the most widely used internet modeling method is graph theory. The weaknesses that still exist in internet topology modeling research are problem of accuracy, completeness, and applicability. We move to internet topology mapping. We have specific conclusion for them. Mapping internet topology at the AS level is mainly in the form of effort to obtain maps of relationship between ASs on the internet, which is generally confidential data belonging to its internet provider. Understanding map between ASs on the internet is very important in order to understand the structure of the internet topology and also for the benefit of future internet development. The main problem that remains an open problem in mapping internet topology is the problem of incomplete mapping of links between ASs, especially for peer-to-peer links. We go to the last conclusion for internet topology measurement. Measurement of internet topology is often done to see trends and evolution of internet topology over a certain period of time. The measurement process carried out can be globally or regionally. The trend and evolution of the internet topology are very important to measure because we can see the growth of internet topology and we also can predict of its development regionally or globally. Various components can be included in the research of internet topology measurement. One component that is widely measured is IXP. Common weaknesses in measuring internet topology are the limited number of vantage points and their uneven placement in all parts of the internet topology globally, as well as the limited public access to internet topology measurement points, which are mostly private. So that's all the presentation of our paper, a review of internet topology research at the autonomous system level. Thank you very much.
Okay, thank you. Is there any question before moving to our chair for his discussion and input? Okay, since we have no questions, we will listen to you, our chair, for your input and valuable feedback for sure.
Just a curiosity, because I'm asking the importance of using the autonomous system level with respect to a more individual level of modeling, which you could use, for example, when you try to take into consideration the routers, for example, in the network, in internet. So if you use a granularity like the autonomous system level, in which way you can conclude about the structure, how to map the structure of internet, thinking about the evolution, because it is a coarse grain level. Have you understand?
So,
Timotheus?
Yeah, hello?
Yeah,
hello?
yeah.
Are you my question?
Yes, my connection is rather unstable, but I can hear you. I can still hear you, and I also catch your question. So yes, I agree. Our choice is at the level of autonomous system. It is the highest granularity. Yes. Also, of course, other people can also see another focus is interesting, such as when you say that why not you see the focus on router level, because if you can see the router level, you can see the infrastructure, you can see the map of internet more precisely. I agree with that, but but in our opinion and in our topic that we continually working, we want to see the internet economic of an area, of a country, of a continent. Uh, the economic, the internet economic only can be seen by uh, by by using their autonomous system level.
I
Because
understand.
if we see the lower level, which is maybe POP or router, we cannot see the internet economic of certain area. That's why we want to focus at the autonomous system level. That's my answer. Thank you.
Okay, thank you. Thank you very much.
So thank you for
You're
the
welcome.
question, answer, and discussion. And for sure, this will give an impressive idea for the future research and more arguments that we all hoping to hear and see more publication in. Now we will move to the next presentation. Still have two. The next one will be a new way to generate and simulation QKD by Mr. Hassan Abbas Al Muhammad on behalf of the co-authors from the University of Qatar. So the mic is yours, and we are all listening to the presentation.
Thank you.
Right.
Okay. Good morning
Yeah,
for everybody. You see my screen?
yeah, we can see the screen and hear you clearly. Go ahead, please.
Okay. A new way to generating and simulating quantum key distribution. On behalf of the authors, my name is Hassan Al Muhammad from Qatar University. For introduction and motivation, due to the necessity for using the security to the end user, the conventional method for security are not sufficient for the highly equipped attacker and new ways to bypass security. Computers are faster and more powerful. Therefore, this make them a threat for security. For instance, currently much of our communication security protocol rely on asymmetric key system such as RSA. What if someday someone discover a fast and simple method for factoring large prime? Therefore, this will threat the security because the RSA or the asymmetric security is rely on the hardness of the mathematical. Therefore, if we have the computer or a machine that method for factoring large prime number that, such that the quantum computer will be make a threat for this security. One possible solution is quantum cryptography. Quantum cryptography is the art of giving an authorized access to a private record, maintaining the confidentiality and security of files and other activities. There are several methods available for quantum cryptography, such as quantum entanglement, but I will not discuss this type. A photon is the smallest possible measurement of light and can be categorized by its polarity of spin. We will talk about this as BB84 protocol, security protocol. The polarity of photon can be in any direction, north or south or east or west, or any angle between. The polarity of the photon cannot be measured because any attempt to measure it can cause it to change its polarity, because it is one of the principles of quantum mechanics. So what is possible to do? It's possible to produce photon with the particular polarity by passing a stream of them through a filter known as polarization filter. The polarization filter can be thought of as a kind of slot. Every photon emerging from a slot or filter will emerge with the same orientation as the filter. If a photon with the north-south spin meets a slot with the north-south orientation, it will pass through. If the photon with the north-south spin meets a slot with the NS with orientation, it will be blocked. If the stream of photons meet a slot with the south, with northeast orientation, any photon emerging will have the same orientation as the slot. Just in this in the figure, we have this polarization vertical, or like here we have here a photon and a spin with the east-west orientation angle zeros, like here. In the yellow will pass because the orientation of the, or spin the spin of the photon is same with the orientation of this filter. But in the red, here we can see in the red, like in the 135 degrees polarization, or 45 degrees will be blocked because it's not suitable for this filter. Our proposed method is by relying on number. We represent each of these angles, like 0 angle, or 90 or 45 or 135, by numbers, like 1, 2, 3, 4. If we need to creating a shared key, Alice and Bob need to communicate the channel, a quantum channel, a channel that can transmit a photon, such as fiber optic link and other communication channel. Alice has 4 polarized filter to create a stream of the photon, where each stream has one of 4 different polarization. We can see rectangular polarization, such as 0 degrees and 9 degrees. We can see in the table what I mean by these degrees. Also diagonal polarization, 45 degrees and 135 degrees. What I said previous is this will represent by number 1 and 2 and 3 and 4 for our algorithm. Alice and Bob agree that 0 degrees or 135 will represent the binary state 0. 90 degrees or 45 degrees will represent the binary state 1. Our approach is these 4 angles will represent by what I said, it's to represent by the numbers, like 1 and 2, 3, 4. Okay, now Alice generating the first stage of the key stream. Alice generating a stream of polarized photons, choosing random their polarization. Alice transmit this photon one polarization at a time along quantum channel. Alice make note of polarization sequence that she have randomly created. We can see here this a rectangular and this the other degree. For here we can see there is random key stream will be 1101100011. By the way, the photon spin from Alice will be represented in our algorithm, represented by number, like here 1 and 3 and 4 and so on. Crane shared a key. Bob has no way of knowing the polarization of each of the photon has. Bob has 2 detectors, a rectangular filter photon with the rectangular state passes through this filter and change. The rectangular filter change the state of the diagonal polarized photon to a random rectangular state 0 or 19. A diagonal filter photon with the diagonal state passes through a filter and change. The diagonal filter changes the state of the rectangular polarized photon to a random diagonal state 45 or 135. As each photon receives Bob directly at random to one of his 2 directors. Alice and Bob communicate over the standard communication channel to discuss Bob's choice of detector. They discrete all of the wrong bits that Bob obtained with an incorrect choice of filter. The remaining bits are then used to derive the shared key stream. We can see here Alice choose of scheme, like here, rectangular and here diagonal. This is for Alice and sent to Bob. And here represented by the 1 or 0 for each for this spin. Also, Bob choose of scheme like this when the photon come to the Bob. If the polarization is with the spin suitable for the spin, the spin will pass like here. Here just ideal way, just to for example here, because in real life they don't do that like that. Here the receive key will be 110, but because here we can see, because here for after the filter will not pass all the photon, therefore will, okay, the photon will not pass the pop receive key stream will not be like 1 because this one will be there will not be here. After that, we can see if there's an attacker at the middle, or what we said, the filter at the polarization will not suit for the filter. Will be the final shared key 1010, because this not possible from the filter, or sometime there is Eve at the middle, because when man in the middle want to see the polarization, because the principle of quantum mechanics that will make the photon change his status. And when we are this photon arrive to the bulb, will find it will not pass from the filter. Pop received key stream will be 1010 at the end. Okay. The result and evaluation. First, we have taken the other work and compare it with our work. We took the number of sent photon qubits and final key length and analyzed them by using such as SPSS tool to find the correlation. And the left of screen, we can see this the other work. We can see the SPSS, the correlation between the initial number of qubits and the final key length. After that, we draw the final key to the initial quantum photon, and we can see the separate of the final quantum key. And the right of the screen, we can see our proposed method result. We can see is the same correlation between and for the plot we use 7,000 of initial photon up to 7,500 initial photon. Here we can see the proposed method is more flexible, because here in the left hand there's limitation for the other simulation, just for up to 1,000 initial photon. The proposed method advantage. The main benefit of the proposed method is more realistic than the other method, since each number in the algorithm, the random number between 1 to 4, represent the polarization state of the photon. The other method simulates the final decision, 0 or 1. The proposed method actually indicates the randomness of the generation of the quantum key, and the method can also predict the number of each polarization state, such as how many photons with 0, 45, 19 degrees, and 135 degrees can be used for other applications, such as in pure physics. Therefore, in algorithm, it is preferable to use the true random number generated that depend on the physical phenomena. Conclusion: we use the new method. This is the end. We use the new method relies on random number compared with the other simulation. The result are promising. We'll use it for simulate secure IoT devices in the future. Thank you. Any question?
Thank you for the presentation and the hard work. Before moving to our chair, is there any question or anyone who want to discuss, explain, ask for any explanation?
I need a question because it's very important for us, because this is related to my thesis.
Yeah, for sure. Yeah. Any question, any discussion, argument? Okay. So for sure, our chair will ask you the questions that will improve and add the notes.
Yeah, it's very important.
That will make it, that will make it at the right place. So yeah, Doctor, we are with you for your feedback and input.
Doctor?
Hassan, can you,
yes, teacher.
Can you elaborate a bit, just a bit, the validation part of
yes.
your approach, in the sense that you think that it is rather promising, the approach, etc.
Yes.
Do you have some more information about the accuracy of your prediction?
Sorry, the last sentence. I didn't hear the last sentence, please.
Do you have some information which talk about the accuracy?
Accuracy, you mean accuracy?
Accuracy.
Yes, yes,
For my English.
yes. No problem. Yes. But, we analyze the other approach in SPSS to see the correlation between the initial quantum bit with the final key length. After that, we analyze our approach by using SPSS. We can see the correlation is the same in our approach and the other approach. We can see I think the accuracy is good, but we don't calculate it in mathematical. But I think this is a good point for us for my thesis to add this point, the accuracy of the proposed method. Thank you for your question.
Thank you.
Thank you. So now we will move to our last presentation to conclude this session. We will introduce a paper titled as Proposal of a Geometric Method for drop localization with system of multiple directional antennas by Ms. Du Tai Lan on behalf of the co-authors. The mic is yours and we are all listening for the presentation. Ms. Lan, are you with us? Yeah, Ms. Lan, you are now unmuted and we can hear you.
Now I cannot share my screen.
It's fine. You can send it
Yes,
to me by the
please.
chat, or if you prefer, just open a video and make it a talk.
Yes, please
We
try
can-
again. Yes, fine.
You can see my
Oh,
screen.
okay,
Yeah, we
okay.
can see it now. Go ahead, please.
Hello everyone. In this research, the authors are going to suggest a geometric method for drone localization based on system of multiple directional antennas. I will explain this research more details in the next slides. In introduction, I will give an overview of unmanned aerial vehicles as drones and technologies of detection and localization. After that, the architecture of directional antenna system are represented, and then the predicted flight space of drone based on receiving RF signal from drone. Finally, I will conclude the research. Nowadays, drones are becoming more popular and cost of drone is also inexpensive. Therefore, it is therefore, it is easy for everybody to buy a new drone. There are a lot of applications of drone in many fields, such as security, mapping, agriculture, transportation, disaster monitoring. However, the drone is also abused by some people and organizations. For example, posing a threat to the airspace around airports, using for terrorism, attacking restricted areas. Many antenna drone systems with other technologies suggested. Some main technologies of drone detection and localization are suggested. For example, RF, video, radar, thermal, acoustic. In the research, the authors proposes a new method with a system of multiple directional antennas to localize drone. For example, in the figure, in the system, the authors suggest choosing a system so that the vertical place containing the adjacent antennas main radiation directional align at an angle of 30 degrees. As can be seen from this figure, the green beam shows the second antenna's coverage area, and the purple and the yellow beams are of the first and the third antennas. The antennas are placed close together. If the drone is detected by the system, the IF signal of the drone is usually received by 3 adjacent antennas. Each selected antenna in the system has the power half angle as 90 degree and radiators similarly from 0 degree to 90 degree in the vertical plane that contains the main radiation direction. The above figure illustrates the selected antenna beam in horizontal plane in figure A, and in this figure, 2 theta is the power half angle, while the antenna beam in the vertical plane is shown as figure B. This ensures that the system usually scans the drone in all directions. Then I will show the principle of suggested method to localize the drone. The drone is localized by the measurement of the IF signal through the rational antenna system. The drone localization principle is to determine the intersection of 3 beams of 3 adjacent antennas that receive the most vital signals from the drone in the antenna system. Receiver antenna beam is determined through Friis equation 1. Here, the distance d between the transmitter and receiver antennas is reduced equation to P in the equation P is power in watts, R is antenna gain, lambda is electromagnetic wavelength, D is the lifetime distance between the antennas. The suffix R and T denotes the receiver and transmitter respectively. After just due to the transmitter power is not known, we will localize the drone with specific power of transmitter. After receiving the drone signal, the system chooses 3 adjacent antennas that have the strongest receiver power. The system will draw the antenna beams. In this case, the drone may be any position on the antenna beams. 3 adjacent beam to localize the drone, we need to determine the beams of 3 adjacent antennas, and 2 adjacent beams will intersect with an ellipsis. 3 adjacent beams will have 2 ellipses, and the intersection point of two ellipses, that is the drone's position. The figure shows the way to localize the drone with the specific PT and GT. That the red ellipses, the intersect between the brick beam and green beam, and the yellow ellipses is the intersect between green beam and purple beam, and the black point, yes, is the position of the drone. Yes. Next, we will estimate the position of the drone with any transmitter power. If the transmitter power of the drone varies, the position of the drone will be on the green line. That's on the green line. When PT increase K times, D will increase square root of K times with the same receiver power PR corresponding to the case 1 and case 2. Besides, the angles theta and phi in the equation 2 in the previous slide are not vary when PT increases or decreases, so that the angle beta 1 and beta 2 will not vary. And the position of the drone only slide on the green line. Each point on the green line corresponds to a specific transmitter power of the drone. After the system receives the drone signal, a line is constructed such as the possible position of the drone. The drone signal is received twice sequentially. So there are two green and purple lights be the drone. Yes. If the time interval between two receive times is equal to delta t, and the drone speed is v, the distance x that the drone fly within the time delta t is shown in the equation s equals v multiply delta t. Yes, s. If the received power decrease k times, the distance from the drone to the system increase square root of k times. In the figure, the distance d in the first time receiving signal from the drone, and it is the square root of k in the second time receiving RF signal of drone. The localization of the drone will correspond to finding the distance d following the cosine theory in the triangle. Alpha be known when the two green and purple lines are drawn. It is yes, then I will predict flight space of the drone. It is yes, assume that the drone signal is received 3 times continuously by the system, and where there will be 3 positions of the drone determined in observable space. That's 1, 2, 3 positions. By the extrapolation method, the next flight range of the drone will be predicted. We need to estimate the drone's flight spaces. However, the extrapolation method only does in 2D space. Therefore, the authors will extrapolate the next flight range of the drone based on the drone flying range proposition extrapolation. Yeah.
Yeah. So could you please just move to the conclusion to conclude the presentation, because we still have around 1 minute.
Yes. Sorry.
Yeah, could you please just conclude, because we have 1 minute left for the presentation.
Yeah. And this is a nice fly range of drone in space and concludes and future goals. Yeah. Future goals, a new technology should be studied when the speed of drone change. The delay of signal propagation from the drone to the receive antenna is not considered. So thank you for your attention.
So thank you, Valentine, and thanks for the efforts at the great presentation. Dear audience, is there any question, inquiry, request for clarification? Okay, then we will get back to you, our chair, for having your feedback and input on the last presentation for this session before concluding and closure of it.
Okay, and I would ask the following. In the importance of localization and also predicting trajectory of a drone is very important in many practical applications. I'm wondering if your method, your technique could be useful to avoid congestion. Suppose you are in an area where there are different drones, and now we, for example, can have a collision. So it is important to predict the trajectory and also to predict could be some collision. And what do you think should be extended in your approach to allow an influence on drone so that, for example, collision are avoided?
Yes, thank you for the question. Yes, I think yes. Yes, the projection of night fly range of drone. Yes, I know. I want to predict the fly space of drone. I have to estimate the space the fly space of drone on 2D space because it is my it is my suggest method to estimate the next fly space. Actually, I think I have not I do not estimate the fly space of the drone by 3D space. Yes. So I suggest use the extrapolation into the space because I think this method can avoid the errors when I predict the fly space of the drone. Yes.
I think there is the necessity also to interact with drone, having the drone to receive some signal, some alarm, for example, in order to change the direction or their flight.
Yeah.
Trajectory. It is not just using the mathematical method you talked about for predicting the trajectory, but we must influence the drone flight.
Sorry. In this research, it is assumed that the speed of fly is not changed when I estimate because the interval time density is very short, very short, and so the speed of drone can be considered is not changed when I estimate the fly speed of drone. Yeah, because the interval time density is very short when I estimate. Yeah.
Okay.
Yeah.
That's all.
Okay. So thank you for the presentation, the questions, the argument that will for sure enhance the future work and will make the future research become more and more relevant to the recent technologies and implications. So now we reach the end of this session. I sincerely thank our authors for their excellent presentation and contribution in this session and for the participation in International Congress. I hope that the session was informative and knowledgeable as well. For me, I had a heart attack from mathematics, but after seeing the presentations and the ideas, to be honest, I changed my mind that it's really reliable to be applied and extended to other sessions, ideas and papers. So all participants will have their digital certification within a couple of business days. So please make sure to check your emails regarding the publication. We have already communicated the Springer and they will be there within 4 to 6 months for sure. You will receive emails and we will wait for any follow-up or questions during this period. I would like also to thank our chair for his input, questions, and argument, which for sure enhance the ideas of the researchers and the presenters. We are thank you on behalf of ICICT 2021 and the Global Knowledge Research Foundation. Thank you everyone for being here, and even it's virtual, but we will still have a chance to have a picture and keep it in our records and memory. But for sure, next year we will be together physically because the humanitarian system is stronger than any difficulty. So please turn on your cameras and let's have our picture now. Cameras on.
I would express to all the authors, presenters in this session, my appreciation. Although I'm not an expert in the communication area because I'm from computer engineering, I have, in any case, have the possibility to understand the hard work which was behind some presentation. And I would also encourage authors to continue and explore and improve their work. But remember, when you do a model, please check its validity with a strong validation work, because otherwise results, experimental results, can be of limited importance. So please improve, still improve our work, and remember the importance of making comparison with other tools, with other approach, with other authors who have made similar things. Thank you again for good work and presentation. Thank you again.
Thank you, Doctor, and thank you for all our presenters. For sure, we will put your advice as an ear of our ring, as a ring in our ear, and we will follow up your advices as a senior expert in research, regardless of the area and specialization. We highly appreciate this. So now let's have our picture and close the session. 3, 2, 1. Okay, we are done. So thank you all and have a nice day. We hope to see you again next year with better circumstances, and we are thankful for your time. Our next session will start around half an hour from now. So we hope to see you all there. Thank you again. Take care, stay safe, and have a nice day. Thank you. Bye-bye.
Bye-bye.
Thank you.